You have one cube, you have a million cubes. Minecraft. Do we have any errors? No. An error. We have one. A triangle. That's worrying. Oh yeah, it works. We've done it. Oh no, I'm a fool. Blah, 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 blah. Wow. That is not what was expected. This is a mess. Hi, I'm Oliver Age 24. In this video, I'm going to try to recreate the whole of Minecraft in only 1 hour in Unity. Obviously, that's probably going to be impossible. So, as we learned from the last video where I attempted to make The Sims in an hour, you have to really pick one specific thing and focus on that. I think for this challenge, I'm going to focus on making a cube at runtime dynamically, because that's something I've never had to do before. So, I've jumped into Unity, I've got a brand new project open, and I've got an hour on the clock. So I'm going to try and see how much of Minecraft I can remake in just 1 hour in Unity. 3, 2, 1, go. Timer's ticking down. I'm going to start by making a new empty object, and I'm going to call this managers. Zero it out at 0, 0, 0 and make our first script. And this is going to be voxel engine, which is going to handle all of the voxels in the world. We're going to start out, and maybe it'll take the whole hour, by making just one single Minecraft cube dynamically at runtime. But if we get that done, then we can make more cubes, which is basically the concept of the game, right? You have one cube, you have a million cubes. Minecraft. That's what the movie is as well. So I'm wasting loads of time here waiting for Visual Studio to open up. Okay, right, let's go. So I'm going to delete all this, and we're going to start with a mesh filter, which I believe I've done a bit of reading and having a look at how this should work. I'll make a new object called chunk holder. A chunk, I learnt, is what they call it in Minecraft, probably in other voxel games as well, where a bunch of them are rendered together to optimize it a bit. So you only render the voxels that are right next to your character. So I've added a mesh filter, and I think I also need to add a mesh renderer. And I think with both of these things, we should now be able to render some voxels. I'm also going to make a material so that it shows up. We'll call this voxel material. So we've got a material there, we can just throw it in there. And then in theory, anything we make in this mesh should have this material. And I'll just color it green. Now jump into our manager, voxel engine, edit script. I'll make that public so we can drag and drop it in. And then we will do an awake. And then I believe to make a mesh, you basically need a list of vector frees, and this will be our vertices using system.collections.generic, and then you can use lists. We also need to add a private list of ints, and that will be our triangles. So we've got vertices and triangles, and UVs apparently as well. I don't know if necessarily you need to do UVs though. Hopefully we won't need it. What do we need to do? We'll do a public void create, and we'll start with a triangle. Create triangle. And to create a triangle, we need to know vector free 0.1, vector free 0.2, and vector free 0.3. We've obviously got 3 points in a triangle. We will want to add each of these points to our vertices. We'll add 0.2 and vertices add 0.3. Let's do a public void create cube, and then in here we'll call create triangle, and then we have to give it some coordinates. So just for now I'll just put vector 3.0, vector 3.0 and vector 3.0, just so it has all three. And then public void create mesh. So to start with, we need to mesh, we'll call it mesh, equals new mesh. And then to set our mesh, I think we just do mesh filter dot mesh equals mesh. And then I think as well as that, we can then do mesh.vertices equals vertices.toArray, and then mesh.triangles equals triangles to array. So that'll convert our lists into arrays, which is what this uses. But then we actually need to decide what is on our mesh. So I'm going to do create cube. So then that'll call this create cube, and then that will call create triangle. So we're going to try and do our first triangle. I guess we'll start at the bottom of the cube and we'll do the first quad on the bottom, and then we'll work our way up and around the other sides. So since we're doing this in triangles, let's just zoom in so we can see what we're doing. Let's do this 0, 0, 0, 1, then 1x, 0, 0, and 0, 0, 1z. And there'll be our 3 points that we're going to do here. We can actually just put them here so we know we want to do vector 3, 0 is actually correct. And then we want to do vector 3.0, new vector 3, it would be 1, 0, 0. And then this one at the end would be new vector 3, 0, 0, 1. So that should then create our vertices, and then we need to add a triangle. And the triangles work a bit differently. So add 0 would mean add the first vertices in our list as a point on the triangle. And I think you have to always add 3 values, and then it will connect them together to make a triangle. So we've added our 3 points there, 0, 1, and 2. So that'll be those 3, and it'll connect them together into a triangle. And I think I read that the order that you do these determines whether it faces up or down. But we can probably jump in and press play now. We didn't set our mesh filter, so that's not going to work. And then we'll grab our chunk holder and put it into our mesh filter. We've lost 10 minutes. We don't have anything yet. I'm hoping a triangle will render now. I don't see anything, so hopefully it's upside down. It is not upside down either. That's worrying. I thought that would work. Do we have any errors? No. We have no errors, but also we don't have anything rendered. Oh, we're not calling create mesh. So let's call create mesh in our awake function. Play. So don't see a triangle, which is fine as long as we see one from the bottom, which we also do not do. We have an error. Okay. So these lists haven't been initialized yet. So we can do vertices equals new list of vector 3 and triangles equals new list of int. And then actually this create cube wants to happen above that because that's where we set those to our mesh. So let's jump back into Unity now. I just want to see a triangle rendered, and then we'll know we're on the right track. We have one, a triangle. It's rendered. And it's rendered the correct way as well, because that is the bottom of our cube. Nice. That's really exciting. It probably doesn't look like much, but I've never rendered a mesh in code before. So quite an exciting moment. I'm wasting time there, so let's get over it and get on with it. Okay, so create triangle. So then we'll create another triangle, and this one will be on the opposite side over here. So instead of this point, let's start with this point over here. So this one will be new vector 3, 1x, 0 height, and 1z. And then we'll move to this point, which would be the third point from before. So we can grab this one again there, and then back to the second point from before. So 1, 0, 0. Jump out of it, and it should be a square now. The shadow by default is looking really pixelated. I'm not seeing the other triangle. It might be upside down. It's not upside down either. Oh, we're overwriting the other cube when we add the triangles. So actually, instead of 0, we want to add the place in our triangle list that is. So triangles.count. And then this would be triangles.count plus 1, which means this one would be triangles count, you've guessed it, plus 2. So we don't see anything from above. That's fine. Some indices, the plural of index, right? That feels like a made up word, but I think that's correct. Failed saying triangles. Some indices are referencing out of bounds vertices. I don't know. I feel like I've just lost the ability to speak English. Index count 6 and vertex count 6, so actually should be 6. Oh, wait though. Because I'm adding 1 already to that, I can just do triangles count because it's already increased. That looks really weird though, doing 3 times that, but that's fine, I suppose. Yes. Cool. Ah, that's awesome. We have a square. And yep, you can't view it from above because it's just one-sided faces. We've dynamically drawn a square. So now we're going to try and draw... Should we draw the top? Let's draw the top, actually. That's probably easier. We've used 18 minutes so far. We might get a whole cube done, which would be pretty exciting. Okay, so create cube. Let's see. Next, we will create triangle. I'm just going to write above this what this is. So this is actually bottom face. This one's going to be top face. Create triangle. So this will be vector3 dot 0, 1, 0. New vector3 0, 1, 0. New vector3. We want to go the opposite order to what we did on the bottom because we're on the top. So it would be 0, 1, 1. And then new vector3 1, 1, 0. And then we want to do create triangle, new vector3. Same again, we're going to do 1 above what we did last time. So 1, 1, 1. And then new vector3. So 1, 1, 0. And then new vector3. This one, but 1 higher. So 0, 1, 1. That should be the top face of a cube. Oh yeah, it works. Oh, that's awesome. It's hard to tell, I guess, because of perspective. And when it's a cube, you don't really notice that you can't see the inside faces. So that's the top one done. Let's now try and do, I guess, the front face. So this will be create triangle, vector3, 0. And then, I don't know which way we want to move to make it draw properly. So let's just move upwards. New vector3, this will be 0x, 1y, and 0z. And then new vector3, this will be this corner, so that'll be 1, 0, 0. Cool. And then create triangle, new vector3, it'd be 1 in the x-axis and 0 in the y. No, 1 in the y-axis and 0 in the z-axis. 0x, 1y, 0z. And then the last one would be new vector3, 1x, 0y, and 0z. Let's see if that works or if it's the wrong way around. We should see a whole face here. We can see half a face and half a face the wrong way. So the first one we did is correct. The second one we did is incorrect. So this one, we just move it to this side. I think that should flip it around so it faces the outside. Press play, let's have a look. Nice. Okay, so we have the bottom of the cube, we have the front of the cube, and the top of the cube. We're getting there. Let's do the back of the cube next. Back face. And then we'll just copy our front face, and then we're going to move it 1 across in the z-axis and flip it around as well. Let's just turn that into a new vector3 0, 0, 0. So to move it back 1 in z-axis, we just add 1 to all of these. 1, 1, 1, and 1, 1, 1. And then if we just flip these around, it should go from a front face to a back face, which will save us loads of time if that works. A bit of time. Enough time in a 1 hour challenge anyway. 25 minutes and we have half a cube done. It's not the most impressive. I'm impressed because I've never made a mesh in code before. So it's quite exciting. I hope it is exciting to see as well. Otherwise, this might be a very boring video. Okay, we've got a back face now as well. So we've got bottom, back, top, and we have the front. Now we need to add sides onto this cube. We'll call it left face. And then we're going to obviously want right face as well. So for the left one, we're going to do, let's just copy and paste this. We're going to want 0, 0, 0 to begin with. So 0, 0, 0. Then we're going to move up I guess, to 0, 1, 0, 0, 1, 0. And then we're going to move down here to, that would be 0, 0, 1. 0, 0, 1. Nice. And then this one would be, if we go top corner there, it'd be 0, 1, 1. 0, 1, 1. And then we'll move down to the bottom corner. So that would be 0, 0, 1. And then this would be top corner again. So 0, 1, 0. And hopefully we have a left face. Or we might have to flip them around if not. Stop. Play. It hasn't worked. But is it just the wrong way around? It's just the wrong way around. We can see it inside. So we can flip those. Before we flip them though, let's just copy those into the right one because they are the right way around. So we can grab this, copy it, delete that, move it across here. And then the same with this one. We copy that, move it across. Okay, so then on the right face, we need to move it across 1 in the x-axis. So just 1, 1, 1, 1, 1, and 1. So that should, in theory, create a cube. And then we've got half an hour left. Nice. That is a cube from this side, and a cube from this side, cube from this side, and a cube from below. We've done it. We've created a cube entirely using code in Unity. It's a voxel cube. There we go. Exciting. Okay, so now we've made one cube. We should probably make loads of cubes. But we can only make a cube in this specific spot. So we probably want to give it a vector 3, which would be the starting position, starting pos. And then we want to give this vector 3.0, and that will make a cube here at position 0, 0, 0. And then in here, we could just add the starting position as an offset to all of these vectors. So I'm going to change those as well from 0 to the actual values, just so it all looks the same. We could add in an offset here. Let's put the offset in with the triangle, shall we? Vector 3 offset. And then we can just add the offset plus offset into each of these. And then into each of these, we can just add the starting pos. Copy, paste, 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 paste. So let's just test this works by doing create cube, new vector 3. We'll just do a bunch of different random ones. So in fact, we could just put random dot range between 0 and 10. And then same again, random range. Is that wrong? Oh, use random dot range instead. Okay. Random dot range, 0 and 10 again. And then random dot range, 0 and 10 again. I'll just put that in its own function so I can call it a bunch of times. Public void create random cube, and then we'll throw this into there. And then here we can just do for int I equals 0, we'll go up to I is less than, let's make 25 random cubes, I plus plus, and then we'll just call create random cube. Let's see if that works. That seems to have worked. So we have 26 random cubes. They're all the same object technically, like they're all the same mesh, which is why we don't have loads of objects in the scene. That is really cool. And if I move that, they'll just move together. That's cool. We're dynamically creating these cubes using our script. I guess next we want to make a chunk. Let's delete that bit now. So we're not going to create the cube that way. We'll do a public void create chunk. Let's say a chunk is 10 by 10 by 10. For int I equals 0 and I is less than 10, I plus plus. And then we'll do for int j equals 0 and j is less than 10, do j plus plus. And then we'll do for int k equals 0, k is less than 10, k plus plus, k plus plus. Then if j is less than 2, then we will create cube Our starting pos will be new vector free ijk. And then that should make a square 10 by 10 with 2 cubes of thickness. Play, in theory. No, nothing. Why would there be nothing? Oh, it's because I didn't put create chunk here. You make lots of careless mistakes when you try and go quickly. I do anyway. ADHD, I'll blame that. So there is our mesh, which is 2 high and 10 across by 10 across. We probably want to add like a bit of height, like fluctuating up and down. How can we decide? We can do float noise equals math dot, no, noise dot, is it math dot Perlin noise? Let's try that. And we'll use J and K. No, we'll use I and K because the height is J. Then we should get a noise. I think it's between 0 and 1. Yeah, between 0 and 1. So we can do, if noise is more than 0.5, then we will create an extra cube. No, that's wrong, isn't it? A better way, I guess, to do it is to store the values of... We could store a height number. That also won't work. Let's create a structure. So public struct. We'll call this voxel pos, as in position. And that will have a public int x, public int y, and public int z. And also we'll do a constructor. So public voxel pos int x, int y, int z, and then yeah, this dot x equals x, this dot y equals y, this dot z equals z. We're going to make a dictionary, private dictionary of voxel pos, and we could use an int value to decide what type of cube is there, and we'll call it chunk1. Chunk1 equals new dictionary. And then in create chunk, we won't actually create the mesh. We'll public void create mesh from chunk, and then we'll do create mesh from chunk here, mesh from chunk, and here we will do create chunk. How are we going to do this? We're going to use that noise thing I was just trying to use. And basically we'll do for int I equals 0, I is less than 10, I plus plus, and then we'll do for int j equals 0, j is less than 10, j plus plus. And then for the k value, we're not going to do that. We're going to do int height equals math dot Perlin noise ij, and that will give us, well, no, we'll do float. We'll get a float value for that. We will clamp it or turn it to an int. We'll multiply it, height times, let's just say we're going to go from 1 high to 3 high. So we'll go times equals 3. And then we'll do height equals math dot clamp height between 0 and 3. And then we will do int height equals math dot round to int height. And then we should have a height. And then we will do height int plus equals 1. Because we'll add 1 on, so there's always at least 1 cube for the floor. And then we should be able to do for int k equals 0, k is less than our height int, then k plus plus, we can do chunk 1 dot add new voxel pos I j k, and the value would be 1 instead of 0, because 0 would mean it was empty. Then when we create the mesh from the chunk, we'll do for each key value pair kvp in chunk 1 voxel pos and int, then kvp dot value and dot key. So we know if kvp dot value equals 1, that means we've got a block, and then we will do create cube, and we'll use kvp.key.x. We'll make a new vector free kvp.x, kvp.key.y, and kvp.key.z. And in theory, when I press play, it should make a block 10 by 10 with heights that go from 3 to 1. Maybe. Fingers crossed this works. Wow. That is not what was expected. Okay, well, we've still got 11 minutes to work out what on earth just happened. Oh, okay. So when we're creating a chunk, J actually should have been the Z, and K is actually the height. So that would go there. Then why were they all the same height? Okay, I think it's because Perlin noise, I don't know if from 0 to 1 on int is always the same value. So we need to divide, we need to do float I divided by the size of our chunk, which is 10. So divided by 10. And then the same here, float J divided by 10. And I think that should work. We do have a slightly raised bit. How can we do more of that? We maybe need an offset. Vector free dot offset. When we add the voxels here, we could add offset.x plus offset.y and plus offset.z. Why does it not like that? Float to int. Oh. Okay, yeah, we'll change that to voxel pos. And then when we create the first one, the offset will be new voxel pos 0, 0, 0. And then we'll also create chunk new voxel pos. Let's try and make the next one along. So 10, 0, 10 and see if that works. And then we could also, I guess, do a few more. So create chunk new voxel pos 20, 0, 10. And we'll do 30 as well. Create chunk new voxel pos 30, 0, 10. Okay, let's try that. We've got 8 minutes left. That just might be big enough so we can see there's more like hills and stuff. Because at the moment we only saw one tiny hill. And I just want to see if we can see some more hills. Okay, so that is literally the same one duplicated across the different ones. That's weird, isn't it? So does Perlin noise keep repeating itself? Where we divided it by 10, maybe we want to divide it by a much bigger amount. So like divided by 1,000. Why have these moved across 1? Oh yeah, because I don't know why I did that. I put them all back to 0, 0, 0 and 10 across, 20 across. So these will move across in a row now rather than a weird diagonal situation that we had there. Okay, it's loading. We've got 6 minutes left. Woo! I quite want to like jump in and like run around on the level, but I don't know if I'll have enough time to make a character controller to do that. It's now flat, completely flat. I feel like we're close to making it work. Just something's not quite right about maybe this. Let's find that 10, that 1,000. We'll just make it 100, 100. Maybe we try a different type of noise if not and see if we can get that to work. Oh, okay, that's done something. It sort of looks like walls now. Interesting. Very interesting. Okay, I'm going to try different values. I think let's try like 20 and see if that works. I think we just have to keep trying it until we get the right value in there, because that will scale it. Okay, that's definitely interesting there. It's always the same is the only issue I'm having with it. Oh, because we're not adding the offset plus offset.x and plus offset.z. And then if we jump back in, then hopefully it won't be the same. Because I was just wondering why it was so like, well, literally the same each time. But it's because we were literally putting the same starting position in and we were offsetting the noise by the position of the chunk. There we go. Now that definitely looks odd. It's kind of working. It's just not really what I would have expected. What are we doing here? We're doing something wrong. I'll lower this back down to 10 now as well. because the noise is a bit too frequent. We've got 2 minutes left. I don't think we're going to have time to run around in the level, but we might get the noise working correctly. I don't know quite why every other chunk was incorrect. That's quite odd. Now they're all broken. Perfect. Oh, it's because I didn't put float here. What a potato. There we go. Because the offset is an int value, and that was dividing by 10 and just either equaling 0 or 1 or whatever. That was the issue there. No, he's wrong again. Do you have to put that in brackets like that? I think it'll do the divisions first. Oh no, I'm a fool. This is a mess, but oh no, I've got a minute left. And that was me thinking I would have extra time. I think that might work. I've got way too many brackets in there. I don't need all those brackets. I'm just panicking because I've got 44 seconds left. Okay, we might just have time for one more attempt if this doesn't work. It's worked. That's what I wanted. We've done it. We've dynamically created a Minecraft-esque world there. A mesh created entirely by code of voxels. The next thing to do, I guess, would be when you click on one, it pickaxes it away, and also having a character. Boom, we did it in time, an hour. I was hoping to get one cube dynamically made, but we got a lot more than one cube. We got a chunk of cubes, which is a 10 by 10 square of randomly heighted blocks. So that's a pretty decent start for 1 hour of making Minecraft. To go from never having worked on voxels or dynamic meshes to creating this feels like a good use of 1 hour worth of time. So yeah, while we didn't manage to make the whole of Minecraft in 1 hour, hopefully you enjoyed this video. I enjoyed doing the challenge. Please hit like and subscribe if you did enjoy it, and leave me a comment. Let me know what you thought, whether you've ever tried to make voxel stuff before, if you learned anything from this video, and if you've got any ideas for future videos that you would like to see. Thanks for watching. Goodbye.